Okay, so differentiation calculus, okay, it's fundamental principle whether that we're looking at the gradient of a function or the rate of change of a function. So initially, we've got our average rate of change. And if we go back to what we first looked at with our gradient of a line, y2 minus y1 over x2 minus x1. That's what this formula is. There's x, that's the y value. There's x, that's the y value. So really, my average rate of change is the gradient of the line joining the points, all right? So where we used to write y2 and y1, that's the same as x, x1, y1, x2, y2. Okay, so it's my gradient rule. So we've got a chord. Okay, they've got different terminology. The chord is just a line that joins the points. All right, where x is equal to 3 and x is equal to 4. Find the average rate of change over the domain of 3 to 4. So often in this case, we get the x value is equal to 3, corresponding y value is equal to. Well, we've got to work it out. And the y value is given to us by 2x squared. So 3 squared is 9, 2 times 9 is 18. So there's one coordinate. And then we've got at x equal to 4, the y value is 2 times 4 squared, which is 32. So my average rate is equal to 32 minus 18 over 4 minus 3, which is 14 over 1, which is 14. Okay, so there's my average rate of change. All right, so it's the gradient of the line at that point. Now, I'm not too sure what happened to my printout here, boys, but this is telling me that a rule to find the gradient of the curve at a point. Okay, so that's the gradient. So up here, that's the average over that interval. But what actually is the gradient at that point, or at that point, or at that point? All right, that's what this notation is about, and that's where that terminology comes from, f dash of x. At this point in time, we refer to it as the gradient at the point, and that's equal to the limit as h approaches 0 of f of x plus h minus f of x over h. Now, if you remember from last year, couldn't emphasize it enough, that's really just y2 minus y1, and that's the difference in the x values, okay, which we term our step size h. So that formula, my first principles formula, is just given to us. It's just a form of my gradient rule. All right. So a couple of things first. When we evaluate limits, all right, really what we're saying is what does this value become as h gets close to 0? All right. So in reality, all we do is substitute h into h equal to 0 into whatever expression we've got. So in this case, if I put h equal to 0, that's 0, that's 0, I get left with 2x squared. If h is 0 here, I get 0 over 0. If ever you get that, it means we can cancel something. So if we look at the top line, I could take h out as a common factor and get 4x squared plus 3h all over h. So those h's cancel. So therefore, the limit as h approaches 0 of 4x squared plus 3h is simply 4x squared. All right. As h approaches 0 here, well, there is no h value, so that's just equal to 5x. And there's no h value here, so that's just equal to 3. All right. Now, that leads us to one of the first things we did last year with our calculus, and that's finding the derivative from first principles, all right, which is using that rule up the top there that's in red. Now, we don't have to do it often, and the reason we do it, let's consider what that rule up here says. So if I've got my axis and we've got a gradient, and all we're saying is if that's the x value, that's the x value plus a bit more. All right, so my two values, that's x, that's f of x. That point there is x plus h, which means the y value is f of x plus h. So x, x1, y1, x2, y2. So this rule up here, f dash of x, I'm going to write out again now. F dash of x is equal to the limit as h approaches 0, f of x plus h minus f of x. And I'm just going to put the second y value, x plus h minus the first y value. So hopefully you can see y2 minus y1, x2 minus x1. X minus x is 0, and so I just get the limit as h approaches 0, f of x plus h minus f of x over h. So that's just my gradient, and what we're saying is, as h gets really small, okay, with smaller and smaller h value, well then we get closer and closer to a straight line if we zoom in. So to actually work out the derivative from first principles, let's work out our f of x plus h, well that's equal to x plus h squared plus x plus h. F of x is simply x squared plus x. So now if we just work out what the limit is, I'll go to black. The limit as h approaches 0, let's expand that term, hey? I'll use green because that's green up there. So we'll go x squared plus 2xh plus h squared plus x plus h minus x squared plus x all over the h value. So if you do that right, x squared minus x squared, x minus x. The x's will always cancel off. That leaves me the limit as h approaches 0. I'm going to take h out as a common factor. That gives me a 2x plus h plus 1 all over h. They cancel. So it's the limit as h approaches 0 of 2x plus 1 plus h, which is equal to 2x plus 1. So that means that's the gradient at any point. Yeah, that's the gradient of the line at any point, which means it's the rate of change of the function at any point. It's the slope of the line at any point, etc., etc. All right? Just practice that to consolidate what that definition of a derivative is.